So let's look at some examples where we use the method of variation of parameters to come up with solutions of a given differential equation. So let's say, but before I continue, in case you haven't watched the previous video on the introduction to how we go about variation of parameters, check the link in the description and make sure you watch it before you watch this one. Okay, so if you have, I guess we can continue. So let's say we are given d2y dx2 plus y is equals to sec x. Okay, sec x there. So remember, the first thing that we do is that we solve the differential equation that you have. So in this case, the differential equation that we have is m squared. Let's say from the auxiliary, from that you have m squared plus 1 is equals to 0. So meaning our m is equals to positive or negative I. Where does that come from? We have it's supposed to be positive, and this is supposed to be equals to positive or negative square root of negative 1. When I take it this side, it becomes negative. Okay, so and you know to say root of negative 1 is simply I. That's why I indicate it like that. So meaning the coefficient of that is a 1. So that's meaning the roots that we have, those are complex roots. Okay, so meaning our complementary function is going to be equals to e to the px. In this case, our p is 0, like we don't have anything. Remember to say it's supposed to be like p positive or negative. This is supposed to be positive or negative q, positive or negative iq. So our p, we don't have any real part. Our p is a real part, we don't have anything, that is to the 0. So meaning e becomes 1. Okay, e becomes 1. So I'll just say we have like a cos x plus b sine x. So why am I saying sine x? We are supposed to multiply that by q because our q is a coefficient of I, which is a 1. We just leave it like that. Okay, so now what happens is that we observe to say our y1 is equals to what? Is equals to cos x. Our y2 is equals to what? Is equals to sine x. Remember to say we have to determine the derivatives here. Okay, we have to determine the derivative. So y prime of 1 is going to be equals to what? Minus sine x. Sine x. Then y prime of 2 is going to be equals to cos x. Okay, so and in this case our g of x is equals to what? Is equals to sec x, which is this one here. So when going to Wronskians, which is w, is going to be equals to absolute value, of course. So our y1 is cos x. Then y prime of 1, we have found that is minus what? Minus sine x. Then our y2 is what? Is sine of x. Our y prime of 2 is what? Cos of x, like that. So meaning here Wronskians is going to be equals to this, like major diagonal, cos x by cos x, we get what? Cos squared of x. Then the minor diagonal, we say minus the minor diagonal, because this is negative, that would be a positive. Okay, that would be a positive sine squared of x, which is simply which simplifies to what? To 1. So we find that Wronskians is equals to what? Is equals to 1. Okay, so now let's get to find w1. Okay, so w1 is going to be equals to, here you put 0, here put g of x, which is sec x. Then here put sine of x, which represents what? Which represents y2. Then y prime of 2, which is cos x. So major diagonal gives us 0 minus the minor diagonal, it gives us we say sine x multiplied by sec x. This is just a 1. How is it a 1? Is it a 1? No, 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 no. It's not a 1. Multiplied by 1 over cos x. Okay, cos x, this just turns out to be minus tan what? Minus tan x. So meaning w1 is going to be equals to minus tan x. Let's go ahead and determine what our w2 is. I'll use this same part. So w2, here we're going to have cos x, which is our y1, then our y prime of 1, which is minus sine what? Sine x. Then here I put 0, here I put my g of x, which is sec x. Okay, sec x. So the major diagonal gives us it simply gives us a 1, because cos by sec, and sec is 1 over cos, it gives us a 1. Okay, then the minor diagonal gives us a 0. So our w2 is equals to what? Is equals to 1. Then going to our u1, u1 is going to be equals to u1 is going to be equals to, we are going to say the integral of, okay, what did we say our u1 was? The integral of w1 divided by integral of w1 divided by w, so just minus tan what? Tan x. Okay, tan x dx there. Then our u2 is going to be equals to the integral of w2 divided by that, which is just a 1 here, dx. So meaning our u1 is going to be equals to the integral of that. So integral of tan x is simply minus ln of cos x, but because of that negative, this becomes positive, so that will be ln of what? Absolute value of cos x. Then our u2 is going to be give us what? It's going to give us x. So now remember that we said we already have our complementary function here. Okay, we already have our complementary function. What we are now looking for is the what? Is the particular solution. Okay, what we are now looking for is the particular solution. So our particular solution, okay, our particular solution, we had said it was u1. Okay, it was u1 u1 by y1, something like that, then plus what? Plus u2 by y2. So remember we said we get our u1, we have already gotten our u1, which is that. Then our y1, we get it from the complementary function, which is cos what? Cos x. Okay, cos x. Then our u1, we have found what? ln of cos what? ln of cos x plus what? Our u2, which is x. Then our y2 is what? Our y2 is sine x. Okay, is sine x there. Okay, how then are we able to conclude that? So we can add this with the what? We can add this with the complementary function. So it simply means our general solution. Okay, simply means our general solution is going to be equals to our general solution is going to be equals to something like adding that. In fact, let me just write it as complementary function plus particular solution. Just add this with that, and that's your general solution. Okay, let's try to look at something a little different. Okay, let's say we involve two trig functions. Okay, so now let's say we are given d2y dx2 plus y is equals to sec x tan x. Okay, so now here it simply means that you have your m2 plus 1, okay, plus 1 here. We say that is equals to what? That is equals to a 0. So in this case, our m is going to be equals to positive or negative, positive or negative I, just like in the previous example. So meaning our complementary function, once again, our p is equals to 0. So we're just going to say it's our a. By the way, what I mean by p is, since we have complex roots, it's like we are supposed to have ep x, then you're supposed to have cos a cos qx plus b sine what? B sine qx there, like that. So my p comes from, is the fact that I'm supposed to say p plus or negative qi. Qi is the imaginary part, which is the coefficient of I, which is a 1. Our p is a 0. So if I put 0 there, I'm still going to get the 1. So that is our complementary function. It's going to be equals to, we're going to say a cos what? A cos x plus b sine x, since our q is a 1. That's where that is coming from. Okay, then what follows is that we know that our y1 is going to be equals to cos x, our y2 is going to be equals to sine x, then our y prime of 1, our y prime of 1 is going to be equals to minus sine x, then our y prime of 2 is going to be equals to cos x, like that. Okay, then what follows? Uh, what follows is that we need to use Wronskians, of course. Here we're going to say y1, which is cos x, then in fact, I'm not even waste time doing this, because I already found that this is the same similar thing to as the previous one. So our Wronskians, we found that it was equals to 1. Okay, our Wronskians was equals to 1. So here the only thing that would be different would be the w1 and the w2. So in this case, w1 I put 0 here, then here I put my g of x, which is sec x and tan x, then here I put sine x, which is my y2, then my y prime of 2, which is cos x there. Okay, so now you observe to say the major diagonal is going to give us a 0, then we subtract the minor diagonals to be w1 being equals to what I have here. Okay, what we have here is simply something like, we are saying, what we are saying here is how is this going to be? We are saying sine x multiplied by tan x multiplied by 1 over cos x. Okay, 1 over cos x. How does that simplify? Are we able to simplify that? Okay, this is just going to be, in fact it's a negative, so that should be minus tan squared of x. Why am I saying tan squared? Sine over cos is tan, so tan by tan becomes tan squared. So we find that our w1 is equals to what? Is equals to minus tan squared of x. You can verify that. So we put 2 here. What are we going to get? So for the second one, we can just put y1, which is cos x, then our y2, which is minus sine x, then our 0 here. Okay, then our g of x, we put sec what? Sec x tan x. When we perform some multiplication there, you find that since sec sec x is 1 over cos, you multiply it by cos, it will be a 1, so that will be what? That will simply be tan x. So w2 is going to be equals to tan x. So now we have to determine what our u1 is. Our u1 is going to be equals to the integral of so this would be a minus because of that negative there, so that would be like tan squared x divided by 1. That will still be tan squared x dx. Then we have to integrate that. Okay, so integrating that, you're going to get integrating this, you're going to find that your u1 is going to be equals to what? Minus tan x plus what? Plus x. That's what you're going to get. Then your u2 is going to be equals to the integral of y2 divided by, w2 divided by w1, which is just tan what? Tan x dx there. So our u2 is going to be equals to ln of that. Okay, that's what we get. So maybe I might have made a mistake on the previous one when it came to integrating. Yeah, when it comes to integrating tan x, because let me just try to verify this. If we have u2 to be equals to tan x, of which tan x is simply sine x over cos x dx. If I use u substitution here, I'll say let u be equals to sine x, so meaning u prime or du is going to be equals to cos x dx. Is that going to work out? Not really. Let me let my u be equals to cos. I see if it work out. Let me let it this be equals to cos x. So du is going to be equals to minus sine x dx. So meaning my dx is going to be equals to minus du over sine x. Okay, u2 is going to be equals to sine x, okay, divided by u multiplied by dx, which is minus du over sine x. This goes and that goes, so meaning the negative comes outside, so it becomes something like minus ln of u. Oh, so it's supposed to be minus. Yeah, that's supposed to be minus. So I was right in the previous example. So that's supposed to be a minus there. So now, having determined that, we can say the particular solution is going to be equals to our u1 multiplied by y1, which is cos x there. So this is just going to be I'll say cos x multiplied by minus tan x plus what? Plus x. Then I'll say plus u2, which is that, multiplied by y2, which is sine x. That would be like sine of x. Then that would be minus ln of what? ln of cos x there, like that. So this is the particular solution. So to determine the general solution is going to be equals to the complementary function plus the particular solution. In this case, you just get this, okay, you add it with what? You add it with that. That is going to be your general solution. All right, and that's simply how you answer that one. So there are several examples that we're able to go through when it comes to determining using the method of variation of parameters. But I'm going to end on this one. Otherwise, thank you very much for watching.